Okay, here, solve simultaneous equations. Right, this is a pretty standard simultaneous equation question, probably at grade 4, grade 5, and these are linear equations. That means that these two equations, if I was to draw them, and I'm not saying that they would exactly look like this, but they will look like they will be straight lines. And the solution, what I'm trying to find is where these lines cross. So essentially on this diagram, what are the coordinates of this point? What are the values of x and y that suit both? So if you ever see a question where you've just got a graph, just write down the coordinates of where they cross. Now, we tend to use a system called the 5 S's for this. So I just write the 5 S's down. And the 5 S's at first start, the first S means same. You need to have two of these variables or unknowns the same. I tend to work with x. So I'm looking at the x's. I've got a 3x and a 2x. I want to make them the same. So I can see that I can make 3 and 2 into 6x. So what I'm going to do is I'm going to make the first one, we usually call this 1, and this 2 into 6x. And then I'm also going to make the second one into 6x. So how did I make the 3x into 6x? Well, I did 2 lots of equation 1. And then what I've got to do is do everything times 2. So 2 times 3x is 6x, 2 times y is 2y, and 2 times 3 equals 6. Okay, I then do the same for equation 2. What did I do to 2x to get 6x? I times by 3. So I've got 3 times equation 2. 3 times negative 4y is negative 12y. And 3 times 16 is 48. So that is the S, that's the same. When we've got them the same, the second S is to subtract. So essentially we're taking all of these terms away from each other. And I sometimes write these over on the right-hand side so I can see exactly what I'm doing. I've got 6x takes 6x, and the idea of this is that I'm eliminating it. And this is called solving simultaneous equations by elimination. I've then got 2y take negative 12y. And the reason I like writing these out is because I can then see any double negatives. In this case, I've got a double negative, which is the same as an add. So I've got 2y plus 12y, which is 14y. And finally, I've got 6 take 48. Remember, 6 take 48, we can see that it's negative because it's a small number, take a big number. If you do 48 take 6, which is the difference, that gives you 42. So this is minus 42. So what I've then got is I've got 14y equals minus 42. So I've made them the same and I've subtracted. And now the third S is just to solve this. To solve it, divide by 14, divide by 14. Y equals negative. There are 3 14s in 42, so it's negative 3. So I've now solved it. What the fourth S is to substitute. And essentially that means I'm going to put this value of y either into equation 1 or equation 2. I tend to put it into equation 1, and it is a good idea to show that substitution because it's worth a mark. So essentially I've got 3x plus negative 3. I'm showing that substitution with the bracket equals 3. And of course, what I can then do is make that look a little better. Plus negative 3 is the same as minus 3, which equals 3. Now, so that is the substitute. And finally, I've just got to solve this. Add the 3 to both sides. So what I've got is 3x equals 6, divide by 3, x equals 2. So the answer to the question is x equals 2, y equals negative 3. And of course, if I'd gone back to that graph, it wouldn't have looked like this. It would probably have looked a little bit like this down here, where these coordinates would have been 2, negative 3. Okay, thank you.